C'est comme ça, je vois qu'il y en a.
Voilà. Sur en direct.
Ok. Bonjour, mademoiselle de la Marins. Est-ce que tu m'entends quand je te parle? Tu m'entends, toi?
Non, pas encore. Tu as coupé ton son ou quoi?
Je ne sais pas si tu es en train d'entendre.
Si. Attends. Je vérifie qu'il n'est pas là. Ah, ben il m'a repris.
D'accord.
Bon.
Est-ce que tu m'entends, Amaya? Ok, cool. Merci beaucoup. Merci, merci. Bon, Jean-Marc, c'est bon. Amaya me voit, m'entend, donc nickel. C'est pas pareil.
Blabla. Tu as coupé le son?
Non, non, c'est bon, ça marchait avec Amaya, c'est pour ça que je.
C'est terrible, 13 secondes d'écart.
On va toucher, hein. Ça marche. Allez voir.
Un, 1, 2, 1, 2, 3, 4, 1, 2, 3, 4.
Je recheck avec Amaya. Est-ce que tu me vois et tu m'entends, Maya?
Attends, il y a 13 secondes. Je te vois à peine à l'écran.
Oui, j'entends rien, mais j'imagine que personne ne parle. Attends, on n'entendait plus. C'est good, c'est bon, c'est bon.
Salut Jean-Marc. Salut. Toi? Ah. Work.
So the future lost where to sit.
I don't know if we have a plan on it or.
It's here on the screen.
Do you need them, if you, do you need to plug your computer or it's okay to manage the tray?
Okay, but if I get desperate, I'll yell.
Yeah, okay.
I didn't even bring my charger, so.
Let's go.
Ah, okay, I got a connection.
Hello, good morning.
Hi, Ronaldo.
Good morning.
Can you hear us well?
Yeah,
Okay.
yeah, I think so. Yeah.
Oh.
Hi, hello.
Hello.
Après, normalement, il va le lancer après, si on va en veille, je pense que l'écran, c'est un détail. Parce que, ouais, ça, c'est vrai.
C'est bien de passer le matin.
So, the order of work, this will go is near work last. So after you can last.
Okay.
So,
Yeah. Mm.
This is Jack Laboy.
Welcome you, yeah. You have a nice travel in that.
Yeah.
Yeah.
Where we
To the restaurant, the casino in Dallas. So, yeah.
Well, ça fait maybe.
Okay, d'accord. Then, I don't know if you hope outside or.
Not yet, and you want me to see?
No, maybe she's just. Oh, by the way, if you need to go to the toilet, just. No, already.
Probably would like to do it in the middle of everything. So, no. You do.
You like your coffee?
My review, but it's my stressful moment for her. Probably it's just the waiting.
Do you remember what it was like?
Yeah, I kind of forgotten, but then when we were talking last night, it kind of started coming back to me.
I remember my friends had planned this barbecue picnic,
Mhm.
and we sat on the.
Mhm.
We had I don't remember the taste.
Yeah, I know, it's
It
so
was-
scary.
They were trying to relax me, but there was no way that it was.
So that was
gonna happen.
before.
Yeah.
Oh, wow, I don't think I did anything before.
It wasn't in my control.
Yeah. They were like,
Choice we're
yeah, I
gonna do,
guess,
yeah.
yeah.
After that, it was fun.
Yeah, after it, and just being like relieved.
Yeah. Remember babbling at one point. The dude, I said something about flies eyes, because it's just like a trick. Who was Adam's wife was like.
Wow. Redirect.
Which fly? Which fly? Did it. But
We were just saying this is like, we were just saying this is the most stressful time for Leah, is that like those moments, right?
Yeah, yeah.
Um,
Jonathan? Yeah. Okay, bonjour. These people here have elected me as the president of the defense. So that's why I'm starting. My name is Elisabeth Forskeren, and I'm a senior research scientist at the Norwegian Institute for Nature Research. And my background is from empirical research on reproductive behavior and sexual selection, not in lampreys, but in other species of fish. And I'll pass the word to the other members of the jury so they can introduce themselves. Hope.
Hi, so I'm Hope Klug. I'm a professor at the University of Tennessee at Chattanooga. And my expertise is in animal behavior. So I use a mix of theoretical and empirical tools to understand why animals behave the way they do. And I sometimes work with fish as well.
Kenyon?
Yes, hi, I'm Kenyon Mobley. I'm a associate professor at the Norwegian University. I mess up my own school. It's the Norwegian University of the Arctic, and in the fisheries school. And my specialty is genetics, and I do a fair bit of behavior and behavioral ecology, and in fishes mostly. Thank you.
And Rolando? You are muted.
Is it working now?
Yes.
Yep.
Yeah. I work at the Center for Ecology and Conservation at the University of Exeter in the UK. My work over the last 20 years is based on studying evolution and behavior in a population of field crickets in a wild system.
Yeah, thank you. And then we have the supervisors. Cedric.
Yes. Hello, good morning. I'm Cedric Tellier. I'm an assistant professor in behavioral ecology, and I helped a little bit Léa in her work.
Emilien Lannes, I'm the co-supervisor with Cedric, and I'm working at INREN, UMR Decode at INREN, and I'm a fish ecologist.
Yeah, thank you. And we are here today to evaluate Léa Daupagne's work and possibly grant her a PhD degree. So what will happen is that first Léa will give a presentation of her work, and then there will be a session with questions from us in the jury, and then we will discuss amongst ourselves, and then we will tell you the outcome. So Léa, we look forward to hear you tell about the lampreys and your work.
So good morning, everyone. Thank you all for being here. I would like to thank in particular the members of my jury for agreeing to look at my work. So I worked during 3 years on the lampreys, and my PhD is entitled. I don't know if it's loud or okay. So I was saying that I worked during 3 years on the lampreys, and my PhD is entitled Within Seasonal Variations in the Social Environment from Intraspecific Sexual Selection to Premature Isolation. And I did this work under the supervision of Cédric Tantovic and Emilien. Jean-Marc, tu peux cliquer sur la diapositive. Some technical issues. Let's start. Sexual selection. So sexual selection is an evolutionary force that has been shown to be one of the main drivers of biodiversity and evolution. So at the within species level, sexual selection can result in the evolution of diverse sexual characteristics, for example, by promoting sexual dimorphism, while at larger scales, it can also influence species richness by, for example, modulating speciation processes. So here on your left, it's a recent study from Janik that showed that there's a correlation between the number of species and the strength of sexual selection with the animal taxa. But how to define sexual selection? So sexual selection is mainly defined as any selection generated by differential access to opposite sex mates. So it occurs through two main mechanisms: intrasexual competitions. So in this case, the individuals of one sex compete with one another to have access to the members of the opposite sex. So it's mainly male-male competition, while the second mechanism is intersexual selection. So in this case, the individuals of one sex preferentially mate with the other members of the other sex based on certain characteristics. But if we take a more mathematical perspective, sexual selection can also be defined as a non-random variance in mating success. So why non-random is important? Because for sexual selection to occur, it requires covariance between the mating success, so the number of mates or the number of matings, and a trait that could be under selection. So in this case, you can see that the individuals with the highest trait values are also the individuals with the overall higher mating success. So in this case, there will be a directional selection on this trait. Traditionally, the theory of sexual selection has been closely linked to the theory of mating systems. So mating systems refer to the way populations are structured in relation to mating, and more specifically on the number of mates per female and per male within a species. So mating system can be classified as monogamous, when one single male mates exclusively with one single female, as polygynous, one male mates with more than one female, as polyandrous, one females mate with more than one male, and as polygamous, one many males mate with many females. Of course, here is extreme cases, but we have also intermediate cases. Why is it important? Because traditionally, the strength of sexual selection is based on this mating system classification, and more specifically on the variability in the number of mates within each sex. So, for example, in this extreme case of polygyny, we expect strong sexual selection in males, while the opposite is expected in females in the polyandrous mating system. So here are just some very famous cases of species that can be categorized in each type of mating system. But there are some limitations with using a mating system classification to estimate the strength of sexual selection. So here, for example, you have a case of moderate polygyny. So just like I said before, we expect sexual selection to occur in males. But this is only true if the operational sex ratio is non-biased. So the operational sex ratio, or OSR, is the ratio of the number of sexually available males to the number of sexually available females. When it's above 1, it means that it's male biased, there's an excess of males, while when it's below 1, there's an excess of females. In this case, for example, if the OSR becomes female biased and the degree of polygyny remains the same, there will be no sexual selection in males because there's no variance in male mating success. Another limitation is that the ability to monopolize potential mates is dependent on the current OSR. So the idea that the degree of monopolization is expected to increase with intrasexual competition. So in this case, theory suggests that the strength of sexual selection should be high in females. Another limitation is that the ability to monopolize potential mates is dependent on the current phenotypic distribution. So in this case, for example, if a very attractive male arrives in a mating pool, maybe would be better at monopolizing females. So in this case, we should observe stronger mating monopolization in males. Finally, the last limitation is that the absolute density also influences the strength of sexual selection. So in this case, the OSR remains the same, and the degree of polygyny also remains the same. But just because the density is lower, the strength of sexual selection in males is lowered. Here, what is important to remember is that the operational sex ratio, the phenotypic distribution, and the density are all metrics describing the social environment, and that may interfere with how we estimate the strength of sexual selection. Another limitation with mating system classification is that it's only based on the number of mates. So here we have a strong case of polygamy, and we expect no sexual selection to occur in this system, and we call it a promiscuous mating system. But if we now consider mating success as a number of matings, there could be some variations in the variability of the number of matings between individuals, even if the number of mates remains the same. So to sum up the things that I said in the previous slides, mating systems are generally considered to be quite static because it works on mating system not on one population at one time at one place. And based on that, the strength of sexual selection is considered to be quite constant. But through the last few examples that I showed to you, I showed that the social environmental metrics, such as the OSR, can also impact the strength of sexual selection by influencing the variance of both the number of mates and the number of matings. So it's quite important to consider how those social environment metrics vary based on time. So there's previous work that already investigated how temporal variations in the social environment can impact the strength of sexual selection. And there's one study from Madsen and Shine that investigated inter-annual variation in the social environment. And they showed that such variations also led to inter-annual variation in sexual selections in male snakes. But what happened at a smaller scale is varying within season variations in the social environment. So there's some factors that could lead to such variations. So at the individual level, differences in life history traits. So for example, a differential reproductive timing between individuals or sexes, or differential timing of mortality. And those life history traits also depend on some ecological factors, just like the temperature. And overall, all those factors can impact the social environment in which individuals interact. 15 years ago, there was a study from Kazinovic and collaborators that investigated how demographic variations can lead to within-season fluctuation in sexual selection. And what they did is that they compared selection gradients, which is the variance between the mating success and other reproductive success and a trait under selection at 3 different times within a season. And they showed that those selection gradients differed along with variation in the operational sex ratio. But overall, there's still a lack of knowledge on how such within-season variations could lead to variation in the sexual selection, mainly because mating success is estimated from genetic data. And genetic data are generally obtained at the end of one season. So time is compressed and we cannot investigate those within-season variations. There's also some biases with estimating mating success based on genetic data, but I will not go into that. And even when mating success is estimated from behavioral data, just like the example I showed one before, the number of sapling events is still quite restricted due to mainly methodological constraints. So we still have an inaccurate estimation of the strength and the direction of sexual selection within the season. So to investigate that, as part of my PhD, I use lampreys as a biological model. So they are a good model because some previous work showed that there's some variation in the OSR during one reproductive season, mainly because of port injury. So the lampreys, the males arrive first on the spawning grounds compared to females. There's also some variations in the phenotypic distributions because some works also highlighted that there's FAO-specific spawning association with individuals with large size differences. It's a single pair species, so it means that individuals die after one single reproductive event, and it allows to have the lifetime mating success of individual. It's a polygamy species and with a high mating rate. So my PhD was divided in 3 parts. The first part helped to define how do changes in the social context throughout one breeding season influence sexual selection in lampreys. So it was an empirical approach that we used. The second question helped to define how do variations in reproductive timing within and between sexes affect sexual selection in lampreys. So this time we directly manipulated one life history trait, which is reproductive timing. And finally, the last part of my PhD was to define whether the intraspecific process of sexual selection led to sexual isolation in sympatric species with synchronized breeding patterns. So in this case, we directly manipulated one ecological factor, which is the presence of heterospecific. As part of this presentation, I will only focus on the 2 first questions of my PhD. Okay, so how do changes in the social environment influence the strength of sexual selection in lampreys? To respond to that question, I used 25 adults of lamprey varieties that we measured, weighted, and marked with elastomer for visual recognition. We used 20 females and 15 males. The experiment took place here at the technical platform of the station. So we used a very large circular experimental tank. We used one of the 2 sections of this tank And what we did, we controlled some environmental factors such as temperature, water flow, photo period to mimic the conditions we found on the field at that period of the year. We added 2 boxes with different kinds of substrate, and we continuously recorded their mating activity through 2 video cameras. And the experiment took place at the end of March, at the beginning of the week. So here you have on the left a picture of the vivarium, and on the right, one of the 2 breeding sites. So I'm going to show you the 2 behaviors that we recorded. First, it's a successful mating. So here you have a female, and the male here is coming, and he's going to put his mouth on the female's head, and he's going to grab the female's abdomen. You can see that he succeeded, and you can see the eggs coming out of the body. And then it's a failed mating. So the female is here and the male is coming. And as you can see, he does not succeed at putting his tail on the female. So we calculated 2 kinds of metrics to estimate what we call the potential and actual strength of sexual selection, also SS. The potential strength of sexual selection, so we use the OSR and the opportunity for sexual selection. And we also directly estimated selection gradients on the identified traits. So we identified the body size and first date of mating activity and duration of mating activity. So those 2 traits are related to the temporal swimming pattern of individuals. Concerning the first category, the OSR, so this is a ratio of the number of males to females ready to mate, and the highest, the opportunity for sexual selection. So it's basically the variance in mating success standardized. So the variance divided by the criterion in mating success, and it's calculated for each sex. So the hypothesis is that highest is correlated to the OSR because we expect the degree of monopolization to increase with intersexual competition. So, for example, if the OSR becomes male biased, we expect IS to become higher in males, while we expect it to be lower in females. So the first result, here you have on the y-axis the operational sex ratio. On the x-axis, you have the day of the experiment. The dashed line here represents a non-biased sex ratio, so an even sex ratio. And what you can see is that the OSR fluctuated throughout the breeding and was always male biased, despite the fact that at the beginning of the season, the adult sex ratio, the number of adults in the population, was female biased. So we can wonder why. And this is explained if we look at the two factors, the delay between the start of the experiment and the first mating attempt and the duration of mating activity. We can see that there are sex differences in both the onset and the time span of sexual activity. So in the first case, here on the y-axis is the number of days. We can see that males start earlier and are more synchronous, while females generally start later during the season and in a more gradual way. Here you can see that males are active for a longer time than females. If we now look at highest, so the variance in mating success, so we calculated it as number of partners or as number of matings. On the x-axis is still the day of the experiment. And we can see that in both cases, highest fluctuated a lot and was always higher than the overall highest, represented here and here by a line. So it means that metrics which are calculated each day always overestimate the actual strength potential of sexual selection in the system. Now, if we look at the correlation between IS and the proportional sex ratio, we can see that when it's calculated as a number of partners, it was not correlated to the OSR in males and females. So it means that mate availability is not the factor that constrains the variability in access to mates in both sexes. If we now look at highest calculated as a number of matings, it was correlated to OSR, but only in males, not in females. So what does that mean? It means that mate availability constrains the variability of access to matings, not to mates, in males. Now, if we look at directly the selection gradients and traits. So in our study, we consider mating success as a two-step process. So the individuals first attempt to mate, and then they succeed or not. And we investigated the effect of individuals, genetic or social traits on those two processes. So first, for body size, we constructed a model at daily time steps, and we investigated the effect of both male and female body size, and also the effect of some social environment traits, so the OSR and the size of competitors. And we looked at how it interferes with both male and female body size. So I'm just going to present the results about body size in males. So the hypothesis is that large males have easier access to females. So we should observe a positive correlation between the number of attempts and the male body size, while we expected that females will preferentially select large male. So we should observe also positive correlation on the probability of success and male body size. And we expect that to be even stronger when the competition is high. So here is represented some density plots for each of the processes. So it represents the distribution of the parameter values for both processes. So in the first case, the positive effect, while in the second case, it's a negative effect. So it means that larger males attempt more mating, but smaller males have higher probability of mating successfully. So in the first case, it's something we expected, but not in the second case. This is what we observe. What happens when now the OSR becomes male biased? So in the first case, larger males attempt more mating, something we expected. While in the second case, no, small males had an even more higher probability of mating successfully. So this is what we observed. So just like I said, it was something we expected. Large males have an overall advantage in heterosexual competition and have easier access to females. But these results could be explained in two ways. First, maybe females prefer smaller males, or small males preferentially select lower quality females that maybe might accept them more easily. And this hypothesis is supported by another result. So here in this case, we investigated the effect of a dyadic interaction, which is the effect of the difference in partner size. So here, what does that mean? It means that pairs with similar size have a higher number of mating attempts and a higher probability of mating successfully than pairs with large size differences. So this means that there's a physical constraint imposed by size, differences between partners, while this result means that there's a mate choice in relation to one's sperm size. So smaller males prefer to mate with smaller females. And this result explains why we observe smaller males who have a higher probability of mating successfully, because it results from size associative mating based on mate choice. So for investigating the effect of those temporal sperm importance traits, we also constructed a model at the whole season scale. So in this case, we inferred the effect of male and female body size and how it interact with male and female temporal sperm importance. So we'll only focus on the first date of mating activity and mates. So in this case, we expected mates starting earlier in the season to have a higher mating success due to increased mating opportunities. So we should observe a negative effect for the first process and a positive effect for the second process. What did we observe? Well, starting date had no effect on either the number of mating attempts or the probability of mating success in males. So this is not what we expected concerning the first process, and yeah, this is what we expected concerning the second one. How to explain that? It was surprising because we expected long rays to have an overall advantage if they start earlier in the season, because we will have an easier access to females. This could be explained if we look at again the graph representing the proportional sex ratio on the y-axis. You can see that the OSR was always lower from day 8 to day 13, but from day 1 to day 7. So it means that mates that started earlier during the breeding season didn't have higher access to females. But we cannot exclude the fact that that observation may be due to captivity, and that maybe in the wild females are more synchronous. Okay, so to resume those results, yes, the OSR fluctuated during the season and was correlated to IS calculated as a number of matings in males. And if we look at the selection gradients, yes, larger males have easier access to females, especially when the competition is strong. So when the OSR is very high. But males starting early in the season didn't have higher mating success due to increased mating opportunities. So overall, what is important to remember is that both the potential strength and direct selection on traits vary according to the social environment. So it's important to consider the scale at which we calculate metrics of sexual selection. Okay, so the second part of my presentation will help to define how the variations in reproductive timing within and between sexes affect sexual selection in employees. So to respond to that question, I mainly used an agent-based model. So an agent-based modeling is a bottom-up simulation technique that allows to analyze the system based on the agents, the individuals, which interact with one another based on certain attributes, individual characteristic, or the attributes of the global environment. So in my model, I had two entities. So first, at the individual level, individuals were characterized by their attractivity, competitivity, fecundity, longevity, as well as the timing of variable. While at the global environment, at the population level, three factors were modeled: the breeding scenario, the level of asynchrony, and the level of density. If we look at more closely to the individual characteristic, there was two traits, one attractive trait and one competitive trait. The attractive trait defines the gametic investment of the individual. So the more attractive you are, the more fecund you are. So we consider the attractive trait to be an honest indicator of one individual's fecundity. Those three traits represent the reproductive function of one individual. And we consider the trade-off between the energy allocated to the reproduction and the longevity of an individual. And the longevity is modeled as the number of mating opportunities, so how long an individual can stay in the mating pool. So to sum up, if you're highly competitive and or attractive, will not stay very long in the mating pool. But on the opposite, if you're not very either attractive or competitive, you will stay longer. At the scale of the population, so it only presents the result considering the breeding scenario. I will not talk about is the level of asynchrony or the level of density. So we first had two scenarios. So here, the first scenario, SF-SM, for synchronous females, synchronous males. So in this case, all the individuals in both cases are synchronous at the beginning of the season. The second scenario, AF-SM scenario, in this case, only males are synchronous. Females arrive in the other way. And those two scenarios, we also investigated how it may affect the shrink of sexual selection in both cases empirically. So the hypothesis concerning the first scenario is that the OSR should be non-biased at the beginning of the season. So the capacity of high quality individuals to monopolize males should be low, and the strength of sexual selection should be weak, and there should be no differences between males and females. While in the second cases, as males only are asynchronous, we should observe male-biased OSR. So in this case, the capacity of high-quality males to monopolize males should be high, and it should be strong sexual selection in males. So how did we do that empirically? So we also used the experimental tank here. We had two experimental groups. In the first group, so what we call the synchronous group, 10 males and 10 females were present at the beginning of the season. While in the second group, only 2 females were present. And every 2 days, we added 1 female until 9 females were added. So overall, it took 18 days to have the density. We also modeled different scenarios in the agent-based model. So this is all the possible combinations. So here, this is the SF-AM scenario. In this case, this is the males, which are asynchronous, And finally, the last scenario where everybody is in asynchronous. So you can see here that scenario 1 and 4, there's no intersexual differences in emerging synchrony, while for the scenario 2 and 3, there are intersexual differences in emerging synchrony. So this is the process overview. First, individuals arrive in the melting pool according to their timing of arrival, which is dependent on the bridging scenario. Then individuals encounter according to their competitiveness. So this trait, so the more competitive male will meet the more competitive female, etc. And then they decide or not to mate with each other based on their respective attractive trait values. So the male choice is probabilistic and it follows an open-ended preference function. So this is a sigmoid, which describes that the individuals with the highest attractive trait have a higher probability to be selected by their potential partner. I will not go into detail, but if both individuals accept mating, they will form a mating pair. But if one of them rejects mating, in this case, they will not form a mating pair and they will not be available for the current time step. So there's a cost at being selected. And etc. Then there's a gamete release process. So it's directly related to the gametic investment trait, because if both individuals accept mating, female produces an average 60 eggs. So we base this according to the ecological love rate, and then the gametic investment trait reduces. So there is less gametes available for the next mating. Then the individuals leave the pool according to two traits, the gametic investment and the number of mating opportunities. So when there's no gamete available, or when the maximum number of mating opportunities is reached, they leave the mating pool. One generation is one simulation in the agent-based model, and I will present here the simulation with a low density. So we did that to mimic the condition we had in the experiment. We had 11 males, 11 females, and we did 100 simulations for each scenario. So the different metrics that we used, we also calculated the opportunity for sexual selection, and we looked at selection gradients on the attractive trait, the competitive trait, and the timing of arrival. The opportunity for sexual selection, variance in mating success standardized. And for the selection gradients, we were interested to see if there's any kind of selection and if it's whether directional, disruptive, or stabilizing. So here, this is the result for the agent-based model. So each point represents one metric calculated from one simulation. On the y-axis, you have the highest calculated as a number of partners. On the x-axis, you have the breeding scenario. So in purple are the scenario where there are intersexual differences in breeding synchrony, while in orange are the scenario where there's no intersexual differences in breeding synchrony. And what you can see is that when there are intersexual variations in reproductive synchrony, there is sex differences in IS. So if we look at more closely, IS in females is higher when they are asynchronous, but males are not, while IS is higher in males when they are asynchronous, but females are not. So this is contrary to what we expected. IS was higher in the asynchronous sex. And what happens now if you look at IS calculated as a number of matings? So we can see the same pattern, but there's overall less variations across simulation and fewer sex differences. More variations, sorry, between simulations. Now, if you want to compare IS from the model and IS that we estimated in the experiment, so the red points here represent the IS we estimated in the experiment. And we can see that it's quite similar to the one obtained in the simulated population. If we now look at selection gradients on competitive traits, so we can see that in the AF-SM scenario, so only when females are synchronous, there's a positive directional selection on the male competitive trait, while it's always stabilizing around mean values in the other scenarios. And the same pattern is observed in female when they are synchronous, the males are not. So what does that mean? It means that competitive individuals will produce more when the opposite sex is asynchronous. Now, if we look at the attractive trait, we can see that the AF-SM scenario, it's only a stabilizing selection on mean male values, while it's always directional in the other scenarios. So this could be explained by how we model the trade-off between reproduction and longevity. Because when the OSR is male biased, so in the case of the AF-SM scenario, it's too costly to be both attractive and competitive. So in this case, higher competitivity confers higher mating success. But in the non-biased sex ratio, the breeding scenario, so you have, for example, the AF-AM scenario or the SM scenario, when the OSR is female biased, so for example, the SF-AM scenario, in this case, high competitivity does not bring a mating advantage. So in this case, being highly attractive is better. And this is also the same pattern that we observe in females. Now, if we look at the timing of arrival on individuals, in the AF-AM scenario, when everybody is asynchronous, there's no correlation between mating success and the timing of arrival. So early arrival individuals do not maximize their mating opportunities. But now, if we look at the scenarios where there are intersexual differences, there's a negative correlation between the number of matings and the timing of arrival. So it means that there's a directional sexual selection for early arrival. And what is nice to notice is that in the AF-SM scenario that we did experimentally, we observed the same correlation. So females arriving first at a higher number of matings. So how to conclude on that? So when there is no intersexual differences in voting synchrony, this is something we expected. The strength of sexual selection is quite low and there's no sex differences. But when there are intersexual differences in voting synchrony, this is not what we expected. The strength of sexual selection is higher in the asynchronous group, asynchronous sex. So now, if I will briefly summarize the main results of my PhD and try to put them in a broader perspective. So the first part of my presentation highlighted that yes, the social environment fluctuates throughout the breeding season and does induce within season variation in sexual selection. So this is in accordance with a very recent study published by Carleon and collaborators, in which they also investigated and evaluated temporal variations in the opportunity for sexual selection across the breeding season, and they did that for many species. And they also observed a similar pattern. Although they acknowledge that a large proportion of this variation is induced by stochastic processes, still a large variation is still induced by biological processes. So both the study and our reveal that the scale at which we estimate and calculate sexual selection is important to consider. There's one limit is that we all use polygamous species. So I think that future studies should compare longitudinal measures of sexual selection across a wide range of species, from monogamous species to species with more highly skewed mating patterns, just like lake-forming species or polygynous species. It will enable to see if there are any similar temporal trajectories in a mating system with different mating patterns. Second part of my presentation highlighted that when there are intersexual differences in reproductive timing, there is sex-specific changes in the strength of sexual selection. So in the introduction, I said that life history traits mainly depend on ecological factors. And this is especially the case of reproductive timing, which is mainly driven by climatic seasonality, notably through temperature effect. So I think we could observe in species intersexual differences in reproductive timing if there is a sex-specific sensitivity to temperature. So last year, there's a study from McLean and collaborators that did show in the GMAS there are sex-specific sensitivity to temperature. And this led to sex-specific breeding timing. So I'm wondering in those kind of spaces, maybe if they are facing variable temperatures, they will also face sex-specific sperm sexual selection. And the result presented from the second chapter also arise from an agent-based model, but I think will be complexified to better understand mechanism beyond non-speciation. So this perspective is more related to the last part of my PhD that I did not present here, but I think it will be interesting to make the environment spatially explicit to be able to model a sex-specific or density-dependent of the dispersal process, and to also model individuals with alternative life histories, how they could vary both in spatial or temporal context. You probably noticed that I define sexual selection as the introduction of any selection generated by differential access to opposite sex mates. But of course, we know that there's some processes occurring after copulation that also interfere with reproductive success, and notably sperm competition and predictive measures that directly impact the fertilization success of individuals. It's important here because of the high potential for those processes to occur in lampreys, because the fertilization is external, there's communal spawning, the sperm is motile for a long time, and there's sneaking behaviors. So when there's a mating, which is mating pair, which is mating, most of the time you can see a male coming around the mating pair and trying to fertilize the eggs being released. Why is it important here? Because even if you observe a covariance between mating success and a covariance and a trait that could be under a selection, we cannot say if these covariance translate into direct fitness selection on this front, because we cannot say if there's any correlation between the mating success we observe here and the reproductive success. So this is what we call the Bateman gradient. Still, I think that the approaches used as part of my PhD could allow to incorporate those post-copulatory processes. So here I represented the mating success as a two-time sub-process, but we could also include the egg release process, the fertilization process, as well as the hatching success. And all those processes with different biological mechanisms. So as part of my PhD, I investigated how the social environment can influence the strength of sexual selection on pre-copulatory traits, but this could also be interfere at later stage. Of course, these require not only behavioral data, but also genetic data, and I think both are really necessary to get a clear picture of how sexual selection impact a mating system. There's a lot of people I would like to thank. First, again, is members of my jury for being here. And as I'm talking in English, I will start with my Japanese team, Itsuro, Hironori, Chiharu. I spent 5 amazing months in Japan, so thank you for that. Now I'm going to switch to French, if it's okay. Cédric et Emilien, merci beaucoup. J'ai passé 3 ans super. Apparemment, quelquefois on dit que c'est dur la thèse, mais avec vous, ça a été un vrai bonheur. Merci. Où ça va être dur, tout le monde aura au labo, les étudiants, les doctorants, Colin pour m'a validé au début de la thèse, Jacques qui n'a pas pu venir, mais aussi qui a été d'une grande aide, Yves, mais je suis la bonne, hein, qui m'a aidé avec les modèles individus centrés, au début de ma thèse. Voilà, tout le monde. Voilà, merci.
Thank you very much, Léa. Now we go on to the question session. And first I will give the word to Hope.
Great, thank you. So I just want to start by saying that your presentation was excellent and your thesis is also excellent. And you have this really nice mix of the mastery of the conceptual framework that underlies your research. But within your thesis and within your research, you also had this incredible combination of these really complex computational analyses these empirical studies and also this theoretical modeling. And it's incredibly unusual, I think, to see somebody getting their PhD have that mix of like all these different tools and then also this deep understanding of the theory as well. And so that's a really strong component of your research and your PhD. And so I just want to compliment you on that. So I think the way we're going to do this is I'm going to try to keep an eye on the time so I don't take up all of the time for questions. But I'm going to go through your chapters with the questions that I have, and then we'll move on to Kenyon after that. I'll just start by saying your general introduction was really excellent, and to the point where I think it could even be turned into a review. So that's not a question, that's just a statement that you did a really nice job synthesizing the literature on sexual selection. So for chapter 2 was obviously another really strong chapter. And I have some questions, and the questions are more, I think, like discussion questions that I just want your input on. So in this chapter, the primary trait that you focused on when you looked at selection on phenotypic traits was body size. And I think that's a great trait to focus on, and that's the one that I definitely would have focused on initially as well. I also wondered, so sometimes, you know, in fish, we also look at the condition of the fish. So like kind of how fatty they are in relation to how big they are. I'm wondering, do you know if there's any sexual selection on condition as well? Or do you, just based on what you know about these fish, do you think there might be?
So considering how started the experiment, it would have been complicated because at the beginning of the experiment, not all the individuals were mature.
Oh, okay.
So we know that this body condition metric is most of the time used to evaluate the maturity level of an individual. So I think it would have been complicated because an individual didn't have yet all the gametes there. So maybe it would have been complicated. And for the second part of your question about how it would affect, if it could be under selection, the body condition. So it's basically the weight is divided by
Yeah.
Okay. But I think it's quite difficult to separate if the weight is mainly due to the weight of the gametes or if it's rather somatic weight.
Yeah.
So in a sexual selection framework, it's quite difficult to say if it's rather gametes that would be under selection. So, for example, a lot of sperm competition happening, the direct would be the gametes, or if it's more somatic weight. Could be under selection, so it gets more. For example, LGBT under sexual selection. So I think this body condition cannot be distinguished for what type of traits could be under selection.
Yeah.
Still, maybe it could have been interesting to look at, but in our case, it was not possible.
Yeah, and that's a great point. I guess you make a good point there, and like in individuals that are so focused on mating because they don't have much mating potential in the future, they probably are just investing everything, I guess, at that point into reproduction. So yeah. Yeah. When I was reading chapter 2, one thing I was thinking about was that you know, the OSR is obviously changing through the breeding season. But as individuals near the end of their mating period and as the breeding season progresses, individuals have reduced future reproductive potential. So their residual reproductive value is decreasing. And, you know, from a life history theory perspective, even if we were to ignore sexual selection, we would expect individuals to start to invest a lot more into reproduction as the breeding season progresses and they start to die off. And so I was wondering, do you think of any of the patterns that you see across time could be to that, maybe not the change in OSR, but instead the change in expected future reproductive potential, or maybe the interaction between OSR and reproductive potential? Or is there any way to like disentangle the two? Maybe there's not.
So we looked at that a bit when inferring the effect of the first date of mating activity. So we showed that, for example, in females, they are more solicited by males and they start later in the season, and they are more selective toward males. So yeah, probably because they arrive at the end of the season, they know that there are not a lot of mating opportunities left. They are more selective towards males. So there's no effect on males on that trait, but if we, so yeah, I agree from a theoretical perspective that maybe when you arrive at the end of the season, it should be more, should attempt to mate
Yeah.
a lot more. But if we when we looked at the effect of the OSR, it was a negative effect on the number of mating attempts. So just like you said, the OSR becomes highly male biased at the end of the season. So it's a bit strange because it means when it becomes male biased, there's less attempts. So it will a bit interact with that.
Yeah.
But yeah, theoretically, I agree. But maybe because they're semi-private species, so as soon as it starts, they should try a lot, maybe not only at the end of the season. Yeah, but we try to take that in consideration when looking at the effect of the first date of mating activity.
Yeah. Yeah. And I think one thing that comes out of your thesis as a whole is just that like stuff is complex. Like there's a lot of stuff that's affecting these mating decisions. And yeah. So this is more like a specific question about I guess the methods and the results of chapter 2 still. So you show us that one graph of OSR changing through time, and then it looks like the adult sex ratio is staying the same. But is it really staying the same? Okay, that's what I thought. So yeah, okay. So ASR is also changing. And so I guess similar to my previous question, so you know, our OSR, I guess OSR and ASR are changing in a correlated way. Okay.
It does.
Yeah.
The timeout process, that they, as soon as one individual die, you're out of the.
Yeah, they're out of the mating pool.
And the other situation.
Yeah.
So at the end, I think it will be something.
Yeah.
Similar.
Yeah. So I guess in theory, it could be like some of the patterns, you know, if you think about the mechanisms underlying like what's driving the mate competition, I guess it could be OSR or ASR to some extent. Yeah.
That will be very
I mean,
close, except at the beginning of the season, but
yeah.
Correlate.
Yeah, that's interesting. So one thing that I noticed in your presentation that I hadn't quite picked up on, or one thing that I thought about that I hadn't quite picked up on when I was reading your thesis, is that so the males that start earlier, they don't have better access to females, which is really interesting. And so I was wondering, you know, are those early breeding males, are they just like worse in some way and they know that? And so that's why they have to start early just to like kind of reach the same level of mating success. So like, I was wondering, you know, is there like some cryptic effect of like when males start, because males are kind of self-selecting based on how good of quality they are?
So you mean if you're not really attractive, you will start earlier?
Yeah, exactly. Yeah.
So there was not any interaction between the first date of activity and body size in males. So this is the only trait we identified that could be under selection. So in terms of body size, there's no correlation between the two metrics. But in a more theoretical perspective, probable competition better. But I don't think it would be maybe related to the body size. Just if you are very first, you have more chance to find females which are but do not mate here. But just like I said in the experiment, it was very synchronous. So maybe did not have access to a lot of females. It was well biased as soon as the experiment took place. But with our result, there is no interaction between the first data activity and the size.
Yeah. And so kind of related to that, you know, the body size thing and how it starts out. So the sex ratio is becoming, the sex ratio is changing a lot and becoming more male biased as the season goes on. So the distribution of male body size isn't changing as OSR changes, or is it? They don't start out different, but do you end up with larger, smaller males? Smaller.
Yeah,
okay.
Okay. Smaller. Decision.
Okay. Yeah. So which is how you get this complex interaction between the traits and the social environment.
Yeah, maybe we should have looked at how maybe the difference in size between the first.
Yeah, I was
like,
just
like,
curious about it.
How it changes.
Yeah, and that was one really nice thing about that first empirical chapter was just the strength of it has made me think of a lot of additional questions, you know, that somebody else could focus on in the future. So I'm gonna move on to your third chapter. So this is the chapter where, of course, you used the agent-based modeling, and you also had the study with the lampreys. So this is just like, you know, a general question based on your understanding of the modeling of this particular model. So just, I think all of the assumptions that you made are really good assumptions and very appropriate. But I was just curious, like you modeled the synchrony, asynchrony temporally in your model, and that's great, especially for your system. But I was just wondering, like, in terms of like the results potentially applying to other systems, is there any reason to think you would see differences in the qualitative patterns if you had spatial synchrony and asynchrony versus temporal? And again, like, I know you didn't do this. I'm just curious, like, what your intuition suggests.
Yeah, I really want to do that.
Yeah.
Because, so we take the SF scenario and the SM scenario. So
Yeah.
when there's no intersexual differences, to observe the same thing.
Mm-hmm.
So weak sexual selection, the differences between the sexes. And I think that in the SFSM scenario, if you make the environment spatially explicit, at the end it will be the same pattern
Yeah.
than the FSM scenario, because if you create different batches,
Mm-hmm.
I think within each batch, it will be a very variable OSR. So at the end, I think it will look like the FSM scenario. But the result was the same, so maybe it will not change. But yeah, I think in those two cases, it will be similar. For the two other scenarios, so when there are intersexual differences in synchrony, I'm not entirely sure how it will affect the results if we make it spatially explicit. But yeah, more variations, I guess, in each place in the OSR.
Yeah. Yeah, that was kind of what I was thinking as well, which is like kind of, one, it's kind of interesting if, you know, it potentially like applies more broadly to different mating systems than you even considered, but also then it made me think like, to get different effects of these different types of synchronies, you'd have to like model something much more complex.
Yeah,
I think
it's quite complex.
Yeah.
What you consider as an OSR.
Exactly. Yeah.
Complicated sometimes, then it affects how we so estimate the opportunity for sexual selection, which individual we consider anything.
Yeah, absolutely. Yeah, that's interesting to think about. So this is another like modeling question that's related to how you set up your model. And again, I think that the way you did it is like very valid. So when you added individuals asynchronously, so my memory is, you know, you added a fixed, like one individual at a time. And you had these different density treatments, which is great. So in I think individuals appearing like one at a time is a very reasonable way that they might appear, regardless of density. Another way I was thinking, you know, they could appear is that if you have a higher density, a higher population density, you might expect like a certain proportion or percentage of individuals to appear at any given time. And in that case, like, have you thought about that? And then in that case, I was wondering if you might see less differences between the different types of synchrony if it was instead of just very different numbers of individuals arriving, whether it was proportion.
The same.
You think it would be the same?
If we check the weak asynchrony case, for example, when the density is low, there's a lot of variations in the time step between one individual and another.
Yeah.
But if the density becomes higher, in this case, it will be more individual at each time step for the same asynchrony scenario. So even if you make it like a percentage of the total populations, at the end it will be
it's all
the same under every time. That's what I said, because I created a sequence of possible variable, and when the density was high, as soon as the sequence was full, I made it another one. So at the end it was proportional. very clear.
Yeah,
So I
that
think
is.
at the end it would be,
It just
Well,
changes
that's
like
it.
how the synchrony is done, or the asynchrony is done, yeah, but
it's a bit
qualitatively it should
simplified,
matter.
very high, but in
Mhm.
this case, it will be really proportional number of individuals, however, that I write
Mhm.
each time step, it will be the same.
Yeah, okay.
I think it will be,
Mhm.
similar.
Okay, interesting. So one more modeling question. So like you have this trade-off where the mating traits and longevity trades off, which is what we would expect in most cases. And of course, that trade-off is essential to to keep there being like runaway selection on these traits. Do you think it's like in some cases, like empirically, you just see some individuals that are like just better than others? Like, are there individuals that just are better at attracting mates, better at mating and live longer?
Yeah.
And then the follow-up to that would be like, if you consider that in a theoretical framework, would it
Yeah.
matter at all?
Yeah, for sure.
Like if you relax the trade-off, basically.
Yeah. So some individuals that, in the
Yeah.
case of the second chapter,
Mhm.
large individuals, they have better access.
Yeah.
So if you consider with the agent-based model for in mind
Mhm.
as an attractive, a competitive trait, because that's what I had in mind.
Mhm.
More competitive, the more you have access to females. And we also observed that those large male were more selected by females
Yeah.
because the probability of mating successfully was higher. So in this case, being attractive with the agent-based model could also be under selection. And you're right that some individuals were better at that, and also they had an overall, they stayed longer in mating pool. So in agent-based model, how to model that? Maybe to take that in consideration, maybe not model as strict as it is for now.
Yeah. Yeah, it would have to be like a follow-up model, I guess. that, like
more strict.
with the trade-off, but yeah, and it's interesting. One thing I really liked about that chapter was the link between the empirical data and the modeling, and that's what created a lot of other questions in my mind for future stuff. So as I was reading this third chapter, and this kind of applies to a lot of the empirical work that you did. So, you had these experimental manipulations where you, for example, manipulated synchrony. And I'm not even sure this would be possible like in this system. But what do you think would happen if you experimentally manipulated like the pairings of individuals? Like if you put like a large and a small male together, or vice versa, would they just mate? Would they go ahead and just like mate and have it be successful at some point?
So, for example, if I took an androgynous male and a resident female,
Yeah. Or even in the in the agent-based model in the other chapter, for example, if instead of just like putting all the individuals in the synchronous treatment in a tank together and seeing like which size individuals mated with what other size individuals, like if you actually did like mate choice test sort of where you presented a small male with a large female and a small female, what would happen? Would they just do you think you'd still see this like assortative mating going on where some individuals wouldn't mate, or would they just kind of make it work?
Yeah, this is the difficulty when doing.
Yeah.
You're trying to do observe mating in a more natural way. So you want to see how mate choice occurs.
Yeah.
A lot of choice, while you just put individuals in one situation, they do not have any choice. So it's difficult to really infer male or female preferences.
Yeah.
But I think they will try. There's something I wanted to do with agent-based modeling to observe because size-associative mating is a pattern that emerge.
Yeah.
So I really wanted to do that in the model to see. So to model individuals with different life histories and to see and to model different kind of mating rules. So if individuals do prefer animals with size, or they do prefer individuals with different size, and how at the end it induce those associative mating. But it's more a consequence of the different mating choice that I could model.
Yeah.
That will allow to see that. But yeah, I'm also very interesting to not model any mate preference, just infer the effect of more post-copulatory effect.
Yeah, that would be really interesting.
To also see, able to see if there's any kind of synthetic imaging.
Mhm. Yeah, so this is also in that same chapter, and then I'll go into the final empirical chapter. So, you do see these differences between your measures for the potential for sexual selection and the actual selection you see. And one thing that was interesting is in some cases, when you actually quantified selection on the traits, you get these nonlinear selection gradients in some cases. And so do you think that means that like stochasticity is becoming more or less important under certain conditions, and that's why you're seeing this mismatch between the opportunity for sexual selection and selection on these traits?
So I think you refer to the fact, for example, in the AFSM scenario, when males are synchronous, that's why when females are take the other one. So when females are synchronous and males are asynchronous, they more selection on males for the competitive trait. So this is non-linear selection. And in this case, yeah, because I think that when males are synchronous but females are not, there's less opportunity for sexual selection then, because it's mainly driven towards female arrival and mating pool. So that's why in this case, all males will find the females. It's more about females arriving late that will not mate at all. So that's why the variance in females is higher.
Yeah.
But if we look at the selection gradients, still in this case, the OSR is male biased. So yeah, that's why the selection was more on the competitive trait than on the affective trait.
Yeah. So it's like more of the variation and mating success is related to that trait, I guess.
So the opportunity differences between slices, but when you look at you compare males between breeding scenario, this is the only case where there was some male bias. So that's why maybe it's some discrepancy, we will say, between.
Yeah, so it's not just stochasticity, it's like which trait is kind of most important under, it's
more when you look at the traits under selection, it's more comparing the different scenarios, the different OSR. But at the end, rather than looking at the differences between the sexes.
Yeah, that's interesting. Okay, so I'm going to move on to the next chapter, which is the one you didn't talk about in your presentation, which was a fascinating chapter. I really like the link between behavior and macroevolutionary processes. And then I'll have just a few general questions at the end. And this is just like, this is just one of these questions. This chapter was really nice and stood out, but you noted in one place that you had one male that perpetrated 43% of all aggressions. And I thought this was really interesting. And it highlights the potential importance of individual variation in behavior. And so was there a lot of individual variation in aggression among the males besides like this one male? And if so, what do you think's going on with that? Like, why is this male so aggressive and others aren't at all?
So he was not the only one, but like you said, people think 43% of all the aggressions, still both anadromous and resident also. So
okay, so it wasn't, interesting.
Was the last one. And the one which also attempted the more mating. Because he was able to have access to more females. It was very clear in this case that, compared to the other group, I just had two groups, but compared to the other one, that's a big difference. While in the other group, there was not that much differences between individuals, either in the anadromous or resident type.
That was interesting. So I'm going to go ahead and move on to just a few general questions. So your general discussion and your appendices, which I won't talk about, were also like very well written and very thoughtful. So this is just a general question, which maybe relates a little bit to the failed experiment. So I assume it's better in general for individuals to mate and reproduce earlier because the young have more time to, and you can tell me that. But if it is, do you think there's like strong selection, you know, for both sexes to kind of like mate as soon as they can so that their offspring have more time to grow during the warmer months? And if so, like, is it just a constraint that the females are like not mating like the same way as?
So in the
No.
case of long present,
Mhm.
so
Okay.
it will rather be more just like sexual selection in the sense, yeah, it's about competition, you have
Yeah.
access to more virgin females and males.
Mhm.
So indeed that could be, but I don't think it will be related to the offspring.
Okay.
Because in non-praise, the larva stage it's quite long. So
Okay.
I don't think
So that time is just like a small
Yeah,
part of how long they
it's
have to
small.
feed and grow. So it probably doesn't,
But
yeah.
maybe so they are mating in nests. So maybe if you're the first one mating at the beginning of the season, you have more chance for the eggs to go very deep in the nest.
Yeah.
You will lack of oxygen compared to the
Mhm.
individuals which mate later in the season because of accumulation
Mhm.
of substrate because we have a lot when they're mating.
Yeah.
So maybe in that sense it will be rather negative.
Mhm. Okay.
But
Which is
yeah.
interesting. Yeah, it's just interesting thinking about how like natural selection might also be at play in terms of the, yeah, but it sounds like it's kind of complex and lampreys.
Difficult.
Yeah. So in your discussion, your general discussion, you noted that males with higher mating success face higher sperm competition.
Yes.
And I'm not really that familiar with like the current literature on sperm competition. I just know the basics. And so is like, do you think that's something that applies to other systems in general? And is that something people are thinking about, or is that like something that's kind of neglected in the field of sexual selection that we need to think about more?
I don't think it's neglected. So in the case of my study, I was only able to infer sperm competition based on the successful matings that concern multiple mates at the same time. So I know this is not pure picture of how sexual sperm competition occurs because of course even when there's just one male and single mates with mating varieties would also interfere. But it was the only way I thought about to infer that. But I think that more and more, so the study from Italy, there's a lot of works that he did where he compared the associativity of the mating network to see that when we mate, the female mate with a more polyamorous females, at the end you have an overall higher competitivity with other males. So there's a lot of, so in this case, it's on
they call them jungle falls, but it's just chicken.
chicken. So it's really inferring about type of system, not only fish. Yeah, how mating success would also be related to some competition. But we have one mating system at watch, mating network at watch. It's really looking at the associativity of the network.
Yeah, interesting. Okay, and so this is my my last question. So you know, after reading your thesis, it's like so much stuff matters. So, you know, density and synchrony, and also how mating success is calculated. Like whether you measure things across time versus not, it matters in terms of what you conclude about sexual selection. And so I'm just curious, at the end of your thesis, are you like hopeful about our ability to accurately quantify sexual selection? Or do you think there's still a lot of work to be done and that it's, you know, maybe much more difficult to accurately quantify sexual selection than we've thought, you know, for the past couple decades?
Yeah, I think there's still a lot of things to look at.
Yeah.
And now the next step, I think, to really looking at mating systems that have not really been investigated because there's so many variation in how individual mate at a social from a spatial perspective or from a temporal perspective. So I think it's really important to really consider the mating system you have under study.
Yeah.
So I think that there's a lot of things to be done. Maybe the main thing to remember from my thesis is that behavior is important, especially when you look at mating success. So
Yeah.
it's important to consider the temporal distribution of your individuals to really know how to measure mating success. And
Yeah.
you know that there's a lot of potential variations in individual activities, especially in non-praise, the duration is very short compared to. It really depends on your system. That's why I wanted to say also with my discussion, maybe in a lake forming spaces, where there's no male who you will know exactly which male is going to be the most successful male. Maybe in this case, would be variations in temporal variations in the stream of sexual selection. So in this case, maybe it's not that will matter on the type of processes. So it really depends on the mating system.
Yeah. Yeah, it made me glad that when I work with fish, they don't breed for very long. So it gave me hope, at least in my system, I could measure sexual selection through time. Whereas, you know, the people that work on long-lived mammals are going to have a much harder time, I guess. Yeah. Okay. So thank you. And that's all my questions.
Thank you, Hope. Then we move on to Kenyon.
Yes. Thank you for a wonderful thesis. I enjoyed reading it 1, 2, 3 times, 4 times maybe. And I also want to echo Hope's words in that I thought the introduction was really well written and thoughtful. It's an excellent synopsis of the current state of sexual selection. And I feel like that could be, I think we both came up independently with, you know, this could be turned into a review or, you know, assigned reading for beginning students. And I feel like you can contribute now by putting your type of work into this as well. So I thought that was really interesting and I enjoyed it. One thing you did mention, so I'm going to be on each chapter, I have like one little sentence that I'm going to pick on, and then there's no wrong answers, but I just want to know more about what you were thinking about when you wrote it. And one is that you had mentioned that scale is important to sexual selection and that averaging values over long periods was something you just discussed. Over either a single season or a lifetime might lead to misrepresentation or underestimation of the impact of selection on phenotypic evolution. And I agree with this, but I'm wondering what the solution is. Do we only take instantaneous measures, or do we try to make something a mean average over time? What it does is it gets to the heart of the question of whether or not we should deal with selection episodes or like a breeding season versus lifetime reproductive success.
Yeah.
So that's a lot of words, but I was just wondering what your insights on this would be.
So in the case of semi-reverse species, it was easier because just work with one breeding season, you have the lifetime mating success. So I think your question is more related maybe to the analysis, additional analysis I did in the discussion when I looked at, okay, it's really time consuming to look at how the behavior is during one breeding season, what is the best if you want, because by doing that, I knew exactly the overall opportunity for sexual selection. So I was wondering, is it better to do it quite regularly, but during just a few times, a very small time snubs. And actually at the end, it's quite similar. The results are obtained from just looking at it every day, just 5 minutes. The overall opportunity for sexual selection was quite similar in these cases. But I think, just like I said to Bob, I think it really relates to the mating system you have under study. In my case, and that's what also Carlier and Reuters showed, is that in polygamous mating system, when you just calculate this metric one day, you're overestimated because you miss individuals that obviously mated, and the mean mating success is lower, so the highest becomes higher. So in this case, in the case of polygamy, it's very, I think, important to really do it quite regularly in time, even if it's not all day long. Just in time is quite important. Which really depends on the mating system you are studying, I think.
Right. What would be an example of a mating system that probably doesn't need to?
Yeah, leg system, aerobic system, what's
Okay.
only one males, one females. I don't think in males, obviously the mating success I think will be quite stable in time. Females, I don't think there will be a lot of variations. Maybe in females a bit, but in I think it will be more stable in time, especially if each individual within one sex are active approximately for the same amount of time. I think it will be more variable. The pressure of polygamous type, I think it's
Right.
They also show, they always show the same pattern when you calculate the opportunity each day, and they did it quite nicely. They look at it, the accumulated opportunity each day, and you can clearly see that it's erodes over time. So at the end, there's no intersexual difference.
Right. I mean, that gives importance to like the changing of selection over a period of time too, which I think is nice. So things at the beginning of the mating season might be under a different scenario versus towards the end.
So it will be even different snapshots of selection across one mating season.
Okay. But do you think lifetime reproductive success then is, I mean, that's the cumulation of everything that you've done in your life. Would that be, it seems like there's a lot of literature that only looks at this, but this is very difficult for lots of us that work with fishes that you don't see on a regular basis that run away in the stream or come back. And so I've always felt that selection episodes are looking at it over a very short period of time, but it's helpful, but maybe not the big picture. Yeah, I know. There's no right or wrong answer. It's just I'm just curious as to what you were thinking. So, thank you. Okay. All right, for chapter 2, I have some very basic, stupid questions. And one is how to identify males and females before you put them into the tank, or could you not do that? Because it seemed like you could identify them in the Japanese species, but then there wasn't a clear.
Yeah, because that's related to what I said, Hope, obviously. We didn't know some individuals, they were not mature at the beginning, and in numbers they're just, we can say if it's a male, female or a male, right before they're mature. So when the individuals were put in the tank, for most of them we didn't even know if they were males or females. So throughout the experiment, we could say in the way they were made, which one was female or male, and also at the end of the season when we collected the individuals, dead individuals, we could clearly see still eggs in females. But even around the urogenital area, we can distinguish males and females. It was just to check if we did it correctly when we observed individuals. So it was very determined, and that's the end more morphological determination.
I was very curious because you came up with decent sex ratios for these experiments, but was that just lucky?
Yeah, but for the proportion sex ratio, we defined that an individual was considered as ready to mate as soon as the attempt to mate, because before that, some individuals we didn't know if they were males or females. So But in the other cases, for example, for the Japanese experiment, I would have considered everyone as zeros OSR because when I collected them, they were all mature.
You watched a lot of videos
Yes.
and you didn't measure aggression for the ones here, right?
No.
But I was curious because you had talked about interruptions in mating, and I wondered, is this on the male side? Is this on the female side? Is it other males that are interrupting? It was just they get interrupted.
Yeah, it was a lot of videos. So overall, it was 9,000 successful ratings. So it was a lot. I saw a lot of aggressions, but I was not able to. It was already too much mating, very high mating rates.
Yeah.
But there were aggressions, and it's only males towards other males. Maybe a few times I observed aggression towards females, but it was very rare, and I did not observe any female aggressions.
Okay.
So that's what I said in the discussion for the probability of mating successfully. It's difficult to say if female are really able to show a female preference because I did not even observe like when they are mating, sometimes they lose the substrate, but there's no clear aggressions towards males. So yeah, mainly males towards other males, but mostly it's before mating occurs.
Okay.
So it's not during copulation when the mating pair starts mating most of the time. It works a young male come around.
And the interruptions, were they just not successful matings where the male pulled off, or is it the female could stop it, or did you? No, it's on the male side.
No, just like I said, sometimes you can see the male is coming around trying to put his tail around the female, and sometimes the female
just moves around. It's difficult.
It's difficult to really distinguish it. It's me making my own perception.
Okay. Do you see any same-sex mating or males doing anything?
Apparently, I was not the only one looking at the videos, but I think there's another internship student that said at some point, yeah, same-sex, but in my case, I did not observe it.
Okay. Curious. Okay, and then I wanted to ask about the density and whether or not the density that you had in your experiment was similar to what was out in nature.
So it was on Lamprey-Phybiatides. Yeah, so usually the density is a bit lower, but still and over researchers shown for this species that sometimes on the same nest we can find quite large densities, like up to 100 individual. So it's rather a high density, but still it's quite something you can find on the field.
Okay, then I have a question that gets to one of your major conclusions of this, which is that mating success was more affected by reproductive timing than phenotypic traits conferring a mating advantage. And I think this is a very profound statement because what this suggests is that there should be much stronger selection on the timing of the mating versus the physical traits that they have. And I wonder if this is specific to lampreys, or do you think this is something that we should be looking at in more species?
Both, I think. We mostly focus on morphological traits, I think, when we look at sexual selection. So I think temporal is really important. Something is not really will interest a lot of people for now. But still, I think the fact that I said this sentence is really related to lampreys case. It's not clear sexual dimorphism in lampreys. That's why at the beginning, when we identify a trait that could be under selection, we said, okay, body size, we know that there's some variations, but we're going to look at some other traits because they're not clear sexual dimorphism. So it's related to lampreys, I think, that sentence in particular. But in general, I think we should look at other traits, not only morphological, physiological, or temporal patterns.
Yeah. Okay. I was thinking, like, when we think of sexual selection, there is usually some very gaudy, ornament or some ridiculous behavior. And I was thinking perhaps one of the different, one of the things that your dissertation did was made me just sit and think for some time. And I was coming up with this idea that maybe this reliability, consistency of a signal, rather than, you know, the variation, the timing that you show up might be one of the reasons why we get lots of ornaments in other species that are consistent. And I was wondering what you think about that.
So I'm not sure to get everything, but
Yeah, well,
the consistency of
yeah, I was thinking that like body trait is a consistent and reliable signal.
Yeah.
Versus when you show up, when you decide to mate, when you're ready to spawn, might be a little bit more subject to the environment or.
So it will either be under weak or strong sexual selection. In a case, it's there's more variability because the factors I could say that one individual is better at coming first is more dependent on variables that are more less variable, that body size, which could be consistently under selected. That's why they're so. Yeah, I think so, but I mainly think because we do not really look at temporal patterns, but also because I think that it really depends on your system. Some system, I don't think for example, when you mean very obvious morphological traits like color, shape, it's really because some organisms really impact how males access to females and male preference. In case of lampreys, maybe you haven't know any morphological trait under selection because it did not compare big advantage lampreys. So yeah, I think it really depends.
I mean, at least to us, at least to you, lampreys look like males and females, right? So maybe there's some obvious trait, but maybe pheromones or something like that.
Yeah, actually, I did. Yeah, pheromones, like spermine. Something I did not presented here as a data for activity impact females, but I showed that they're more selective towards the end of the season. Okay. So spermine have been shown to, so in the sea lamprey, but females are more attracted to males which are releasing spermine. So yeah, probably also it could be selection, trait under selection. It's sexual development.
Or at least it's conserved because that can also activate other species too, right, of lamprey.
Yeah, so for the pheromone, there's not big differences between the species. So it could be as attracted to one species releasing pheromone that the other one. So it's quite similar. There's no big differences between species.
I think lampreys are really neat. I was very excited when you invited me here because it was like lampreys and sex in France, and I was like, I'm in. So this is all, and I also really liked in your introduction the background on lampreys. Yeah, so I've got new stuff to teach in my class. Okay. Let's see. Okay, I think this is still in chapter 2. You had mentioned by approximating the number of mating events with the number of mates, the genetic definition of mating success cannot detect the potential multiple inseminations and thus the degree of mate monopolization. It's a long thing, but what I'm asking here is what is the genetic definition of mating success versus, it's in quotations, so I wanted to know what your thoughts on that were.
Because generally mating success is estimated from genetic data and it's only based on mates that were able to produce offspring, but it cannot take in consideration successful mating, for example, and the offspring died before assembling, or individuals that indeed didn't make it at all. So I think it's remember just the ones that were able to produce offspring and that were sampled at that time. So it does not take really in consideration, really how many times individuals tried to mate, because for the same number of offspring, maybe did not mate the same number of times. So it really, when I said the genetic definition of mating success, it's really just number of mates, but we were able
That were successful.
Which we were able to sample.
Right.
So
Right.
able to sample every egg. So.
Okay.
So it's very good.
Yeah, I was just curious about why it was in quotations.
Something.
Okay. Chapter 3 is very interesting and very dense. It's you've got a lot to unpack in this chapter, but I think Hope covered that somewhat, pretty well. Yeah, pretty well. But what I thought was the most interesting result was that the opportunity for selection was highest in the asynchronous sex, and this does go against what we would expect from like Emlyn and Oring's predictions and whatnot. And I'm wondering if there's a way to reconcile the two. Is there, or do we have to throw out Emlyn and Oring in place of the?
Yeah, so I cannot exclude the fact that the results I observe here is maybe in the way I modelized the asynchronous way. Because in the model I based it on the time I did, how I did it in the experiment. So basically every 2 days I had it one female. So something I made it the agent-based model. But I cannot exclude the fact that maybe the time span was a bit too long compared to, because for some individuals, not in males, but for some individuals, their timing of activity is quite small. So maybe I said, oh, maybe the timing of variable was too long, and it was something that they induced that result. But still, in the wild, the breeding season is quite long. So actually, the strong asynchronous scenario really reflects what we could observe in the wild. So yeah, I'm still. That's what I had in mind at the beginning, and I started to do the model because it was really the weak asynchronous scenario, and I was very surprised. That's why I said, oh, maybe I should, no, there was the other way around. Sorry, I started with the very strong asynchronous scenario, and I thought, oh, maybe it was too asynchronous. So I tried to reduce the asynchronous scenario, but I still observe the same pattern.
Mm-hmm.
So yeah, I don't know really.
I think that's super interesting.
Yeah, it's very interesting.
I'm not sure what to think either.
Yeah.
So yeah. Anyway, that was really interesting. And then you had one sentence on the cognitive ability. The last sentence of the whole paper, that your hypothesis that scramble competition selects for individuals with better cognitive ability, but you hadn't talked about cognitive ability.
No, I
anywhere. This was just
something I had in mind, because this hypothesis is in the scenario where there is intersexual differences in breeding symphony. So, for example, if all males are synchronous and females are asynchronous, I expect there will be property competition in females as the first one to arrive first. And I said, oh, what type of trait would allow that? Maybe the capacity to be more sensitive to temperature or to pheromone, etc. So that's why I consider that cognitive maybe abilities. Because you're right that the trait I looked at was more attractive, competitive trait. And in this case, if you arrive asynchronously for the females, in this case, it's better to be highly competitive. So yeah, it was just competitive trait. I could say it's under selection. And concerning the timing of variable traits, maybe it would be more related to cognitive abilities, but I had nothing to. It was just something I had.
Well, you just take what you just said and write a paragraph and put it in.
Okay.
If you want to talk about that. Because it seems it came out, it hit me like because it was right at the end. And, but I think it was very interesting. Also had me thinking. Okay. chapter 4 with the assorted meeting. I really enjoyed the paper. Yeah, I also wanted to see some presentation on that, but I think it's fine. You had a lot already to do. So, and I really like this idea of being able to test these like 2 different life history strategies, 2 different species or different morphs or ecomorphs or however you want to say it. And the idea of looking at how assorted mating impacts speciation. This is very relevant and people have done models, but we can't go back in time, so it can be very difficult to look at. And I think the simulation's very, very appropriate because you had just few individuals, and that's I've done this as well for assorted mating. So, and you have to simulate data sets. So I think this was right on. But what was so curious is that the androgynous females, I'm having problems talking now, and androgynous females were preferred. So what could be causing the speciation between the brook versus the anadromous, species pairs? I mean, you went to look for that. We didn't see that, but
No.
What do you think could be happening then?
So at the end, I think it's physical mismatch. I was really able to see that when a resident male trying to mate with an anadromous female, he was not able to at all to grab the female and even to fertilize or to go near the reproductive area. So from a biological perspective, yeah, it was a clear physical mismatch, even if they all preferred the large anadromous females. But in the wild, because I also observed a lot of sneaking behaviors, so in my mind, lots of sneaking behaviors. So I thought maybe we are just successful in fertilizing the eggs getting released. So what factor could really induce speciation? But in the wild, there's still some variation in the temporal distribution of activity between the morphs. So the residents usually start mating first, and then the anadromous ones later. So maybe it was rather be more spatial mismatch between the 2 ecotypes rather than self-representative mating based on clear mate choice.
Yeah.
So physical mismatch, but still sneaking behavior. So I think there's some environmental factors that relate to speciation. So
life history traits, including the sneaking behavior, is likely driving these different species, these different ecomorphs then.
For me, it's more a barrier. Sneaking.
It's a barrier.
Yeah, it's really a barrier. So I was wondering what other factors could allow such divergence, and I think it's more the spatial and temporal differences between the breeding season. Okay,
So the non-overlap.
Yeah, because when they're on the same sites, I'm not able to say all the individuals that all the males that snaked the mating pairs really succeeded in fertilizing the eggs. But even if there's a physical mismatch, if there are some sneaking behaviors that, were successful at the end, there will not be any post-mating or post-mating barriers because they all succeeded. And there are some research that showed that at the post-copulatory stage, there's no non-viability of the eggs, or generally
Nobody's looked at that? Nobody?
Yeah, it has been done.
Oh, it has been done.
Yeah, and works, so.
It works. Okay.
Yeah.
Oh, that's really interesting. Okay, so finally the discussion. I don't know how I'm doing for time, but I have some. Okay.
5 minutes to, it's 25 minutes now.
Okay, good. I just have a couple more questions. And I felt like your discussion was one of the most reflective and thoughtful discussions I ever had or I'd read. You included additional analysis and explorations of the data that you didn't put into the other sections. And I felt like that was very enlightening because it tells that you've been thinking about more than what you could include, and it made sense. So you could have just dumped a whole bunch of stuff that you had done in there, but you didn't. You were very curative with this. And you also put your results in a larger context, and you outlined new areas to explore. So I think this was really well done. What I really enjoyed was discussing the failed experiment.
Yeah.
And this is something that, we don't get to publish all of our failed experiments. They sit in a drawer somewhere. So I felt that was great. Good foresight on you for discussing this. And I thought maybe you could just in a few words explain what the hypothesis was for that experiment and why it failed.
Yeah. So the hypothesis, so this experiment was a bit at the beginning, the basis of the idea behind the agent-based modeling. I really wanted to see an eclosure factor that could induce both intersexual and within each sex some differences in the predictive timing. So the idea was, okay, temperature, it affects maturation. So we wanted to test two different temperatures modalities. One of the rise was quite strong, rapid, and the other one was a smaller, weaker rise. So the idea was, maybe if it rises more slowly, in this case, there will be more inter-individual variations in the predictive timing, in the maturation timing compared to a rise, which will be very strong and high. In this case, will be maybe less inter-individual variations and maybe size differences. We didn't have clear hypothesis about that, but it was the idea to see, is there any variations in maturation timing. And why it failed, it was first time that we collected immature individuals in the field, because it was important to mature individuals, and that we tried to maintain them in captivity. And we did that by putting them in very small individual tank. There were no a lot of substrate. So I don't know, it was maybe too stressful for the individual to stay alone in those small individual tank. And also I had to manipulate them every day to check, because it's not very clear sexual dimorphism or sexual maturity traits in lamprey. So maybe just to manipulating them, it was very stressful too. But at the end, nobody matured, nobody mated. So it was a big failure.
Yeah.
But it's right. Yeah, I think it's more the condition in which we maintain the individuals. That's right. Yeah, difficult. But I don't know how we'll be able to do that for lampreys, because maintaining them in the same tank is really complicated because of the pheromone. We wanted to avoid the pheromone.
Right.
Yeah. So it will still be. Yeah, I don't know how to.
You might have to do it in different species.
Yeah, maybe lampreys.
Yes.
Yeah.
No, and I think it's very important lesson, and you learn something from it. So
Yeah.
it's not a total waste of time. Might feel that way during a period of time. It's okay. Okay. I have another sentence that I want to pick on, which is this approach is biologically more relevant as it enables us to define more accurately the covariance between a trait of interest and the number of mates acquired by an individual by excluding prezygotic failed fertilizations, as well as postzygotic embryo death events. Aren't these important though?
It's important, but it's a bit related to what I said. Generally, we consider the number of mates based on genetic data.
Yeah.
Because you cannot exclude, when you do that, you cannot exclude prezygotic and postzygotic failure.
Right.
So I think it's important to consider mating success behaviorally to really see the covariance between mating success and a trait.
Okay.
How this trait impacted the number of mates or matings acquired.
Yeah.
Because you cannot really do it if you base it mating success estimation on genetic data, because you do not exclude those two factors.
Yeah, that what I picked up on is that it's biologically more relevant.
Yeah.
And I'm thinking, and again, this is something that I was thinking about when I was reading it, and that, does evolution care? I mean, you need to, in order for something to be selected upon, you need to make it go into the next generation.
Of course, for sure. That's why I try to represent with the Bateman gradient.
Yeah.
you must first look at the covariance between mating success estimated from the real data
Right.
and the trait, and then look at is there any
Yeah,
relation
yes,
between
yes.
obesity success and mating success? Because you're right, if it's not steep, there will not be any.
Yeah, you can mate as much as you want, but if you don't get any offspring,
Yeah.
and nothing goes into the next generation, evolution pretty
There
much
will be
doesn't
less
care.
selection on this, yeah, for sure.
But what I was thinking about is that, yeah, even those individuals that aren't or are doing very poorly, they still have an influence. So it's almost like there's something extended beyond what I've usually considered to be biologically relevant.
Yeah, right. Maybe the term I use, yeah, biologically relevant. But appropriate.
Yeah, but yeah, I do get that. As a geneticist and somebody that's done massive amounts of parentage analysis, being able to see the translation of mating success into reproductive success, this is what it is for me. But that in no way excludes what you're doing here, and this is super important. I don't know how to say that better. And then finally, you got to post-copulatory processes, which you would need to have some genetic basis for in order to be able to. Yes, I got you. I'm almost finished. I think I have just one more after this. So, and the post-copulatory stuff is super interesting to me, and I think to you too, because you brought it up. But even more so, you talked about sperm limitation and egg competition, and you can even get into like cryptic male choice, which is some things that I've looked at in the past. And I remember writing a paper about egg competition in pipefishes, which is a sexual reverse species. And everybody that was in the sperm competition, apparently it got reviewed by a whole bunch of people. They absolutely hated it, so I had to cross it out of the title and rewrite the title. There was a lot of feedback on it, but maybe 20 years later, or however long since it's been like 15 years or something like that. Maybe we can get back to looking at things like egg competition and sperm limitation in males. And so I really appreciated that section. So I don't have any particular question on that because I'm running out of time.
But yeah, it is something I was surprised too when I was looking at literature. When you type cryptic male choice, there's nothing coming around. Even if some studies done it, but they do not use this term.
Yeah, no, we also had another paper. So we had an egg competition paper and we had a cryptic male choice paper, both of which the titles for had to be changed by the higher ups, the people that will be. The cryptic male choice is where we manipulated a parasite on a pipefish female. So the idea here is do males choose females based on their appearance and no other thing? So we tattooed dots on these females to manipulate a parasite and see whether or not we didn't find anything, but this is something that we had to do. And there's potential ways of doing this, I think perhaps in lampreys as well. So it would be very interesting. Okay. This will be my last question. I'll skip some others. And the question was a bit similar to Hope's final question is, where do we see the future of sexual selection going, the field of sexual selection? You started with that, your introduction, and you finished with that. And what do you think we should explore in the future? And it doesn't have to be lamprey-based.
I would say that it would be nice if behavioral ecologists work more with geneticians to trying to more understand how both pre-copulatory and post-copulatory processes interplay with one another. Something that I'm really into it. Yeah. I would say that being less focused on how mating success, fertilization success, but combining both. That would be nice. We have a clear picture. Sexual selection in mating system. Yeah.
Okay, great. Well, I think you put considerable effort into your thesis. You formulated your own opinions. You presented some excellent work, and that's it for me. Thanks.
Thank you, Kenyon. And then we move on to the Zoom, to Rolando.
Hello. Well, I first want to thank you for inviting me to your thesis. It's really a pleasure to be here. Also, I want to join Hope and Kenyon on their comments about the intro and the discussion that I think are both really good. I also like it a lot, your introduction in the presentation. I think it's very clear. I have very few questions on chapters 3 and 4, so I won't take a lot of time. About chapter 3, I was quite interested in the plot you show in figure 3.4 about the mating success in relation to the time of arrival of the females in the asynchronous group. It's very striking the difference between the first two females that you include from the very beginning of the experiment on the first day, and compared to the rest of the females that you add every 2 days. And I wanted to know your opinion on what do you think, if you think that that might be related to the how old are the females when you put them into the tank? Because I know that in lampreys, once the females are mature, if they don't mate in the next few days, at least the eggs become not viable. But I don't know if that will have any influence on how attractive those females could be for males, or whether that wouldn't change even if the eggs are not.
Yeah, so yeah, you're right. No, I'm not able to say if females that did not mate later were not able to do that because you're right that at the end of the experiment, both females, they still have a lot of eggs in it, but those eggs, because they didn't mate, I cannot say because they over matured, but I don't think so, because when I did the female, they were quite in a good shape. But you're right that at the end of the experiment, I cannot say the latest females arriving did not mate because their eggs were maybe over maturing, or just because they were less attractive to males or not. So you're right that I cannot exclude that. But at least when I added every asynchronous females, they were in good shape and they were.
Okay.
Yeah.
So I think it's most likely because of the males being
I think
older and okay.
Yeah.
That's what you would expect in a
because
similar situation in the field, because the males had to be there before. Yeah.
Yes.
Also, in relation to that, although I think you have answered the question, in figure 3.3, where you compare, where you test the effect of size of both males and females on the mating success, I was wondering whether, because the sample size is limited, whether for instance, in the left plot, you can see that there are some dots in the middle of the plot that are quite high. Could that be more related to the time when the females were put into the tank, what size they had when they were put into the tank, more than with their size itself? I mean, do you think it's possible to differentiate between the size of the female and when that female was put into the tank, at what time? Or do you think this plot might be in part driven by the time when you put them into the tank?
Okay, so I don't remember exactly, but I don't think there were size differences between females. So you're saying that the females that arrived maybe later were smaller than females that arrived first. So maybe they mated less, not because they arrived later, but because of size differences.
That's the question. Whether you think that might be important or.
So I think so, but I think I controlled for that, but I'm not entirely sure. But I would check on it. But I think it was controlled, the size differences between females that were coming.
Okay.
But you're right that if the latest female were smaller, yeah, it would be quite difficult to distinguish which effect affect mating.
Okay, so these plots you control for that already.
Okay, I will look at it.
Okay. And a last question that I guess there is no information about. Do you know if there is any evidence that environmental changes, particularly global warming, could create, in land bridge I'm asking, could create this asynchrony in the wild? Is there any evidence of that? Do you know?
Yeah, so I know with global change, the duration between winter and spring, there's less variations. So the temperature arises in a more, it's less strong. So I think it will create more asynchrony maybe in global change. So yeah, I think in that sense it will affect the synchrony of individuals because the rise of temperature gets.
So do you know if there is any evidence that there are differences between males and females in how that those changes are influencing their arrival to the spawning grounds?
So I know that males arrive first on the spawning grounds, and because they are more sensitive to larval pheromones. But with global change, that part I don't know. Also temperature effects or not. So when it's getting warmer, it also starts, at least in the anadromous species, they start migrating to the spawning grounds. So it's related to temperature too, not only larval pheromones. But I don't know how global change may induce more intersexual differences in that. I'm not sure now.
Okay. And in relation to chapter 4, I saw that there is quite a strong difference in successful mating between groups.
Yeah.
In the plot, there is a huge bar for one group, a very tiny one for the other. Do you know what that might be caused by, or what could be the reason for that big difference?
Because
the position of the groups in the tank, or
one of the two groups, there was very one particular competitive individual, so
yeah,
was the most aggressive and also the one who mated the most. So I think these big differences are mainly due to in one case it was like a keystone individual, in another case it was more different between less different between individuals. So I think it's mainly that driving the differences are so different.
Okay. And also because of the strong difference in fecundity between the resident small females and the anadromous females, I guess that the number of matings they need to release all the eggs will be much smaller in the small females than the big ones. I don't know if you know whether there is the same difference in total fecundity, if there is that same difference in the number of eggs they release on every mating act.
So that I don't know. I know that the anadromous type, the fecundity is way higher, like 10 times higher, even especially in the anadromous Japanese species. Sometimes it becomes very high. In Lampetra philatelids, it's around 20,000 eggs approximately that one female egg has. But at each mating, I cannot say the differences between the ecotypes at the number of eggs released. I would say maybe more eggs are released in the anadromous species, but I cannot say. I'm not sure. From what I saw, I would say there's more eggs released. But the size of the egg it's quite strange, but it's the same in both ecotypes. Yeah.
I was thinking whether if small females need less matings to become spent.
If the same number of individuals are.
Yeah, no, I mean in that case, I guess you would expect less matings with the small females than with the large females because of this. So I don't know if it would make sense to correct for that or not.
Yeah, but the female is one not really difficult because small
No.
they're not interested at all in those females. So
the last question is whether you think you know if there is any evidence of additive genetic variance in this between these two forms. I mean, as a reason for these two forms of anadromous and resident, or if it could be mainly phenotypic plasticity, because that would be a key question to think about, whether this can produce two different species or not. I know that in salmonids there are both things. There are some situations where you have just epigenetic factors influencing having migratory or resident forms, but there are also another situations where you have genetic differences that can drive speciation. I don't know if in lampreys there is any information about that. I know it's very difficult to get, but
so for the Japanese species, we don't have any information. So for the European species, for Lampretia pediatrilis and Lampreta planary, there's a recent study that has been done, and there's really two big islands of differentiation between the two ecotypes, and one is related to osmoregulation process. Because I don't think it's not plastic, and I don't think it will be, because it's quite severe, the difference in life history between both ecotypes. So there's a big, but still the genome is approximately similar between the two species in Europe, but still there's some genetic variations between those.
Yeah, I was thinking more or asking more about the two forms in the same species more than comparing to different species that I guess are well established.
But
so
for the Japanese species, that's what was interesting for us. It was like being at the beginning of maybe the speciation process, a bit maybe for those ecotypes, it's the beginning of the differentiation. I guess there will be no big genetic differences between the ecotypes. Yeah.
Okay. Yeah, that's all from my side.
Thank you.
Thank you.
So I have some questions as well. First of all, I just want to repeat what the others have said, that I thought it was a really impressive thesis, very thorough and interesting. And yeah, the combination of empirical data with modeling, and I didn't know much about lampreys before I read this, but it's a truly fascinating system. And I think it adds to our understanding to, as you say yourself, to add more sort of different kinds of model systems, model species in sexual selection. And this is, yeah, I found it very interesting. So how come you started to work with lampreys?
So at the beginning, I contacted Cedric because I was interested. I was always interested in sexual selection in general, and he explained to me that he was starting to work on lampreys. So I was more at the beginning interested by theoretical aspects of sexual selection and less about the biological model. But then it became quite interesting. So, oh, lampreys, maybe not the best model you think about when you want to study sexual selection. But yeah, that's how it started. At the beginning of my PhD, I had never worked with lampreys before.
Yeah. In the introduction, you talk about the OSR and strength of sexual selection and so on, and you write several places that as females generally provide more parental care than males, OSR tends to be overall male biased. But so in fish, you work with fish, in fish with parental care. Which sex is the predominant caregiver?
I have a doubt, because I know there's a lot of species where this is a male that provide parental care. So I could not say maybe it's equal. No,
Sorry?
it's equal, no?
No,
more
it's male.
male, okay,
Yeah.
it's male and, okay.
Yeah.
No.
So it's common in fish with
Okay.
male parental care. So I just wanted to
Okay,
point out that it's not the whole story,
okay.
sort of, with female care. And yeah, and of course, there's a lot of species without parental care. So
Yeah, just like
yeah,
that.
let's see. I must make sure I don't ask the same questions as the others have done. So in chapter 2, just to clarify, when you, I mean, I think it's I mean, you have control over the lifetime reproductive success, and I think that's really a good thing. Not all studies have that, and then these daily measurements. But then you also have for the whole season, and you say that for the whole season, there's no effect of body size on mating attempts or probability of successful matings. So could you just, I mean, you have touched upon it before, but could you just clarify again, if is body size as a sexually selected trait in your species?
Yeah, so it impacts some other traits. So like, for example, if you're female and you're at first in a mating pool and you're small, you have higher, your attempts higher mating. So the number of attempts is higher in this case. So there's an interaction between some, for example, sperm importance and body size, which is happening. So yeah, this trait would be under selection. But you're right that when you look at as a model that we did at the whole season scale, when we look at the effect alone, it doesn't appear to influence the overall mating success. So yeah, it's kind of difficult to turn about both results basically. Mm-hmm. So, yeah.
Let's see. You talk about well, you showed that the females, they have a very rapid senescence.
Yeah.
So they die very quickly after spawning. You touched upon it with Rolando, but so what's the normal thing? Do they generally manage to spawn all their eggs before they die, or?
So for the first experiment, yes, when we collected the individuals at the end of the experiment, they were completely depleted. There were no more gametes available. For the Japanese species, at the end, even the individuals which mated a lot, they still carried eggs at the end of the season. So I don't know, I would say that maybe depend on the species or the conditions. But in the case of the Japanese species, they still had a lot of eggs. So it was logical for those individuals, obviously, that did not mate. But even for the very successful individual, they still carried a lot of eggs. So yeah, I couldn't not explain why. The density was lower in the Japanese groups. So maybe that's a factor that they interfere or less nice opportunities because there were the two archetypes, so maybe they were more restrained. That in the first experiment, which was the same species, so that's why maybe the rating rate also was higher.
And here in the French species, do you have data from the field? I mean, if you look in the gonads,
it's complicated because they die very rapidly,
yeah.
So you cannot find dead bodies in the field.
No, yeah.
So complicated. So
okay. Yeah. And then I'm very interested in this whether there are mate preferences and whether females can exercise mate choice. And you discussed a bit with Kenyon about what controls unsuccessful matings.
Yeah.
So I just want to know what happens before the mating. Do the individuals meet each other? Do they see each other? Is there courtship? Or
Yeah, so there's not clear any clear kind of courtships. The only one maybe will be because they construct nest. So maybe individual males that construct the most beautiful nest, or which is the most active. Maybe it would be untrained under selection, but in lampreys it's very difficult because as soon as they mate, it's fully mating, has a high mating rate, so it's very difficult to distinguish. Like you said, are they mating or not? Yeah, they're mating always. So it's gonna be difficult to identify one.
So do you know the male makes the nest, and do the female sort of swim and inspect different males above the nest, and then they just attach themselves to a stone?
So they also participate to the nest construction.
Yeah.
But yeah, there's a study from the lamprey, I think, that they showed that lampreys move more than males between nests, but it was the density was lower because in the sea lamprey it's less polygamous, it's more monogamous. So yeah, it moves. I would say that in lamprey that it does the same. Male arrive first, construct nest, and then females arrive and move between the nest. But still, you can find males building the same nest. So, yeah, maybe it will be a trait that could be under selection under female preference.
Yeah, interesting system. Let's see. Yeah, I have to come back to this with the reproductive timing again. It's quite complex how it works and how you talked about that it could be the environment or that affects. Do you know? Could there be? What is the selection acting on? What kind of traits? If it is selecting, if selection is acting on the trait that affects the timing, is it? Yeah, what could it be? Could it be the developmental time for these stationary species, or could it be how fast they come back from the sea?
Yeah, I think
and how well the condition, the food they ate in the sea, or how do you know?
So I think for the resident species, they migrate, but not that much, just a few kilometers compared to the anadromous species, which have to come back from the sea. So that's maybe why the resident species start to mate first compared to the anadromous one. It's more related to that, but after really at the within sexual level, I think it will be a bit related to what I said to Kenyon earlier about combat competition. So traits that could be under selection that are called cognitive abilities, so central individuals that may be more sensitive to temperature or pheromones that are able to come to the best spawning site first and start building nests and then females arrive. So maybe it could be a trait that may create inter-individual variations.
Yeah.
But between the ecotypes, I think it's more related to the life stream.
So in chapter 4, in the Japanese lampreys, you mentioned, because you measured body length and body mass, as you did in the other species, and then you mentioned something I thought that was very curious, that the males developed dorsal fins just before onset of spawning, but you didn't measure that. No. so it's only the males who have this?
So in the sea lamprey, this is considered as a trait that could be under sexual selection. You can see bigger the dorsal fin in males. But in a Japanese lamprey, even in the anadromous type, I did not observe any clear differences. At the beginning, it was correlated to the length of the males. That's why I looked at it, but I did not consider because it was correlated just like body mass. So I don't know why in the sea lamprey, not in other type of species. But yeah, I would like to look at more closely, maybe to some morphological traits that I didn't look at.
Yeah.
And of that, apparently in some Japanese species, the eggs of the females are bigger than males, so things like that. I don't know, but in the case of the species that I'm interested in, I did not look at it.
No, yeah.
But yeah, you're right, it happens before maturation. So yeah, I thought that maybe it would.
So if there is a lot of variation between the males in the proportion how big the fin is, yeah, I don't know. Yeah, I was just curious to hear that it developed just before.
Something I did not do, maybe look at the difference between the beginning and the end of the season also becomes introduces less in individuals, in some individuals that others maybe. Yeah, I don't know. I just like looked at it at the beginning of the season, but maybe I should.
And the others, they also commented upon the large individual variation between the males. And of course, this makes, the obvious solution is to have more replicates, of course. I'm sure you, yeah. So some parts of the study, it's difficult to draw sort of conclusions regarding some parts of the results. But apart from that, I think that this chapter 4 was really interesting, and that you sort of link it also the reproductive behavior to speciation processes, and I found that really good, really interesting.
Sorry, I didn't present it. But it was a present.
So which part of the work did you enjoy the most in your thesis work?
I must say that in Japan it was quite it was quite complicated to find the individuals in the field.
Yeah.
It's very difficult, but at the end we found enough to do 2 groups. It was very nice because I was able really to construct that project beforehand and to do that on my own there and see that it could work. Paper on it, so it was nice to see. Yeah, enjoy it.
And my last question. So if you got a very big grant to work on lampreys for the next
I will not.
3 years, no.
That's unacceptable.
Yeah. So what would you like to do?
Go back to Japan. I really want to complexify the agent-based model and try to make the link between the structure about the agent-based model and the part, the study that I did in Japan. I really want to incorporate post-copulatory processes and to see how it interferes with the pattern I observed there. So I think it will be the first step. I really want to complexify it because for now it's still a very
but only the models, nothing sort of empirical.
Yes, so we have now a nice new facility here in Saint-Vincent that I think Cedric will show you later today. And I think it offers quite nice opportunities to better understand, because the experiments I did it in vivarium in very restricted conditions. So in a more natural setting, it will be nice to investigate, especially how the spatial distribution, how it interferes between species with alternative history, how that interferes with the pattern observed. So yeah, combining how I would like to complexify the model and maybe do an experiment in the artificial river that we have here. I think it would be nice to find experiments on the model. But no, I will not work on non-phrase work.
No, yeah,
It's not the plan, but I will work on it later.
yeah. Thank you. So, yeah, I'm happy. I hope you are happy.
Yeah.
So last, I'd like to give the word to the supervisors. First to Emilia.
Thanks. So as a supervisors, we are not supposed to make comments on the thesis or the presentation. So I'm just gonna say a few words about some traits of personality of Léa and some qualities that make me think she's already a good scientist and at least a very good colleague. And so I'm gonna switch in French. It's gonna be easier, and so the parents can hear some nice words about their progeny. Donc, quelques mots de contexte. Alors moi, je suis co-encadrant. C'est surtout Cédric qui était, on va dire, en première ligne et qui m'a proposé ça, peut-être d'abord parce qu'on est copains, et deuxièmement parce que j'avais un peu d'expérience sur les lamproies, sur l'écologie des lamproies. Et par contre, j'étais complètement naïf en matière de sélection sexuelle. Donc, ça t'a certainement demandé un peu d'effort pour me présenter les choses quand on fait des réunions de façon pédagogique. Et ça, c'est une qualité qu'on n'a pas trop évoquée encore. Et la pédagogie, c'est quelque chose que tu maîtrises assez bien, ça se voit dans ta présentation. Et j'avais juste une question par rapport justement à l'enseignement. Est-ce que c'est quelque chose qui te branche ou...
Je sais que ça prend beaucoup de temps.
Ouais.
Donc, je sais pas, plus recherche, je sais pas, par-ci par-là, peut-être donner quelques cours, ça me branche très bien, surtout sur la section. Mais vraiment avoir des heures comme ça régulières, je suis pas sûre que ça peut être merci.
Un trait de caractère qui était assez marquant, c'est que tu avais comme tu l'as dit, tu avais des idées assez claires sur ce que tu voulais faire en entrée de thèse, donc c'est assez rare finalement. Des étudiants qui savent vraiment ce qui les intéresse. Et ce qui n'était pas facile, c'est que tu as réussi à transférer cet intérêt à un modèle biologique que tu ne connaissais pas, qu'on connaît, même nous assez peu en tant que spécialistes, on maîtrise assez peu. C'est une espèce qui est en sous-étude. Donc il y avait quand même une grosse prise de, enfin pas une prise de risque, mais un risque quand même. Tu l'as vu avec des expériences. Mais finalement, soit c'est un risque que tu as réussi à maîtriser. Alors pour l'expérience ratée, je pense que c'était presque plus une autre faute à l'encadrant que la tienne, parce que c'était en début de thèse. Par contre, pour l'expérience au Japon, là, tu l'as géré toute seule. Et ça s'est super bien passé. Donc, je pense que tu as eu de la chance, mais aussi tu t'es vraiment bien démarré. Déjà pour définir le sujet de recherche, pour t'entourer bien sur le terrain avec les collègues japonais que tu connaissais pas du tout. Donc, tu as aussi un peu une capacité à gérer des projets qui est assez notable. Quand tu as une idée en tête, tu arrives à la mener au bout, tu es assez focus. Je pense que c'est ça, enfin, de mon point de vue, alors voilà, je suis un peu plus extérieur par rapport à Cédric, il était spatialement loin, thématiquement un peu plus loin, mais c'est quelque chose qui transparaît quand même assez clairement. Et puis, ouais, assez fiable, très fiable, c'est-à-dire quand tu tiens des engagements, tu donnes des engagements, tu les tiens. C'est vraiment super rare qu'on ait eu des retards de quelques jours. Enfin, c'est quand même super rare. Ça, c'est ultra appréciable. Voilà, tu es très proactif pour proposer des options auxquelles nous, surtout moi, même Cédric, parfois n'avait pas pensé. C'est vraiment très appréciable et très, on va dire, confortable pour des encadrants. Ce que j'avais noté aussi, je vais pas parler beaucoup plus que ça, parce que c'est vrai que je pense qu'il y aura d'autres choses à dire, il va compléter certainement, mais voilà, c'était super agréable de ce travail avec toi. En plus, Cédric, on s'est pas fâché pour ces 3 ans, donc c'est cool. Ça aurait été un peu bon. Et puis, voilà, je pense que tu as des qualités humaines aussi d'intégration dans le collectif scientifique, dans le collectif plus globalement, des capacités à travailler avec des techniciens, des étudiants. Tu as produit d'autres articles pendant ta thèse qui sont un peu en marge d'impliquer d'autres étudiants. Donc, ça montre que tu as des qualités humaines. Donc, je pense que tu as toutes les clés pour faire une belle carrière.
Yeah, and
Yes.
thank you. And Cedric?
Yeah, I will say a few words in English because, and basically it's mainly the thing that Emilian said, but now you get to understand it. And then I will also switch to French too, so the audience can understand. Because you're here today and it's really a pleasure and an honor for us to have you with us, and you're here to decide whether Léa can get her PhD degree. So basically become a researcher, and you will base your decision on 2 things: the manuscript and the oral presentation, which are the final products of these 3 years of works. But we had the pleasure to see the process of doing this, and so we also saw things that are very important for being a good scientist, and we witnessed this. So I just want you to know that these things are among the skills that Léa masters. She gives, and she had original ideas, and she contributed to the writing of the thesis project, which is not that common in France. So for the whole thesis, and then for each part, it's really her ideas that are in her work. And when she had these ideas, then she managed to make them happen. That is, she got some funding for the study. She set up the experiments, those who worked and those who didn't work as well. But she did the modeling, statistical modeling, agent-based modeling. She used method that she didn't know before arriving here. So she was really able also to learn tools that she knew would be useful to answer the question that she asked. She was able to collaborate with other scientists from the lab, from outside the lab, with people we didn't know. And it's really her own initiative to contact these people and to work with them without us. So she worked also with technical staff. She supervised undergraduate students, and they were really happy with the experience. She also gave about 100 hours of teaching during the thesis to undergrads in evolutionary ecology, evolutionary biology and ecology. And it went very well. So yeah, I think that besides the final products, she also has what it takes to be, I guess, a good scientist and one with whom I would really keep working. So yeah, I'm really happy and proud about that. Thank you. And now just a few words in French. Je passe au français, ça va être plus personnel. Il ne faut pas que tu pleures parce que sinon je ne vais pas pouvoir finir. Donc, bon, tes qualités de scientifique, il n'y a pas de problème, tout le monde le sait, t'es très fort scientifique, mais en fait, ça ne marche pas si on n'a pas les qualités humaines qui vont avec. Et il y a 2 traits de caractère, peut-être que je me trompe complètement en mon profilage, que je n'ai pas remarqué chez toi. Il y en a un, c'est le doute que tu as sur ton travail, sur la qualité de ton travail. Et ça, tout le monde doute. Mais il y en a, en fait, ce doute, c'est un prétexte à l'inaction, c'est un doute un peu paralysant. Mais toi, en fait, ce doute, il est combiné avec une détermination assez forte à vouloir faire les choses que tu as envie de faire. Et donc, ça s'est manifesté à plusieurs reprises pour postuler à des bourses ou tu dis, ah, mais je sais pas si j'ai le niveau. Alors, on se dit, ah, là, il faut faire du coaching. Mais si, il est là, vas-y, bien sûr que j'y vais. Il y a de grandes chances que ça ne réussisse pas, mais bien sûr que je vais y aller. Et en fait, cette combinaison de son pouvoir comme une fragilité, quoi, le doute, et puis aussi comme une force et une détermination. Quand on est à côté de toi, ça donne envie de t'accompagner dans tes projets. Parce qu'on se dit, c'est un chouette projet, elle a vraiment envie d'y aller, et elle a peut-être besoin de notre aide. Et je pense que c'est aussi pour ça que tu arrives à... Voilà, que ça s'est très bien passé au Japon, ça s'est très bien passé avec nous, ça s'est très bien passé auparavant avec les personnes avec qui tu as travaillé. Ça va très certainement bien se passer après. Et alors, tu peux te dire que tu as de la chance, tu tombes sur des gens peut-être qui sont avec qui c'est facile de travailler, mais ça vient beaucoup de toi et de ces traits de personnalité qui font que alors, on a envie de travailler avec toi. Donc, je te félicite pour le travail que tu as fait, la quantité et la qualité de travail que tu as fait. Je te remercie pour ce que ça nous a apporté à l'équipe et puis je peux parler un moment à moi personnellement. Et puis, ben, je te souhaite une très belle continuation, une très belle carrière. Parce que tu vaux bien. Merci à toi.
Okay,
Thank you.
thank you. So now, as I understand it, the audience lead to.
Yes.
Is that
Yes.
correct?
coffee this morning. Answering, yeah, especially here.
The coffee left. That was.
Oh, we all stand. Okay.
Yeah, I can say it at once. We are all agree in the jury that we think you have done an excellent thesis, and we want to congratulate you with your PhD degree. So no more worries about that. Yeah, and just in a few words, we thought it was really nice to see you summarize your work and to to sort of in a condensed way to find the most interesting things from the different pieces of the work. And we all think that you have shown sort of a big amount of independence and reflective thinking and originality, and but combining advanced modeling with empirical work. So all in all, we think it's a very strong and very good thesis. Yeah, congratulate you again.
Thank you. Yeah, thanks again for seeing us jury. I'm very happy you liked both of my manuscripts and my presentation, so thank you. Et ça va être compliqué, mais juste dire qu'il y a encore merci. Merci à tous d'être là. Et je dois dire ça, mais j'ai oublié déjà. En présence de mes pairs, parvenu à l'issue de mon doctorat, ayant ainsi pratiqué dans la quête du savoir l'exercice d'une recherche scientifique exigeante, en cultivant la rigueur intellectuelle, la réflexivité éthique et dans le respect des principes de l'intégrité scientifique, je m'engage, pour ce qui dépendra de moi dans la suite de ma carrière professionnelle, quel que soit le secteur ou le domaine d'activité, à maintenir une conduite intègre dans mon rapport au savoir, mes méthodes et mes résultats. Thank you very much. Thank you. Yes, you got great.
Marco, sorry.
Congratulations.
So yeah, you won't be here for the part, which is the fun part. But yeah, hopefully we're going to be in person someday. And if you come over here a long time between Exeter and Asturias, if you pass by the last country, you can stop and visit us and we can talk here, and it will be a pleasure to meet you in person.
Yeah, I'm living quite close to there, so I might go at some point.
Okay. So yeah,
to see
right.
you.
Yes.
So,
thank you.
very nice to meet you.
Bye.
Thank you.
Bye.
Bye.